Good morning, folks. This week we're looking at Chapter 9. Remember last time we discussed the structure of the periodic table, the structure of the electron energy levels, and how those things have to do with the nature and the character of that particular element. So we're going to actually look and see how these bonds are created and why that electron structure is so important. So Chapter 9, Chemical Bonds. So again, the electron structure will explain how and why atoms join together in certain numbers. So let's get to it. So we have compounds and chemical change. So what we're looking for, or what we're looking at, are how elements interact with one another, how they bond, and that results in a chemical change. So we're looking at the atom as the smallest elemental unit, and then we have what we call a molecule. Okay, so a molecule is the smallest particle still retaining the characteristic chemical properties of a substance. So what that means is that we're going to take that substance and divide it down as small as we can and still retain the characteristics of that chemical. So take for instance water. Okay, so if we have water, it's H2O, two hydrogens and an oxygen, and we can take our water and we can divide it all the way down until we have one molecule of water. Now if we divide that molecule, it's no longer water, it's hydrogen and oxygen. So the molecule is going to be that H2O. Now if we look at our examples here, we have oxygen, or a hydrogen gas. So oxygen and hydrogen are diatomic molecules, so they actually bond together in pairs as they're floating around freely as a gas. So whenever we divide oxygen and hydrogen up into their smallest pieces, we find that they combine these diatomic molecules. Now we can split those, and oxygen still behaves as oxygen and hydrogen still behaves as hydrogen, but they'll be a little more reactive because they're not bonded together. If you look at ozone, which is O3, it's a triatomic oxygen molecule, and it's three oxygens that are bonded together. One is not bonded as tightly as the others, so it's very reactive. That extra oxygen likes to come apart and bond with other things. But if we do divide it, it's no longer ozone, it's no longer O3, and it doesn't have the same characteristics anymore. It doesn't have that extra oxygen that wants to react with things. If we look at noble gases, which are on group 8 in the periodic chart, we have helium, neon, and other monatomic molecules. And they're monatomic because they don't like to react. And we'll look and see why that is here in the next few slides. Alright, so what is a chemical reaction? Well, a chemical reaction is the forming or breaking of chemical bonds to form new molecules from old molecules. So we have products, that's what's produced from the chemical reaction, and we have reactants, that's what we put into the chemical reaction and put together or take apart to create those new products. So if we look at these little diagrams here, notice we have water, carbon dioxide, plus solar energy. If we put all that together, we get photosynthesis within a green plant, which produces oxygen. So this isn't a chemical equation per se, but it's a diagram that shows how things can be put together, add a little energy to make that reaction occur, and then what we produce from that. So obviously this is way more complicated. The actual is way more complicated than this little diagram, but it gives us an idea of what's going on. Here we have the opposite. We have plant materials plus oxygen. If we put those together, get the reaction started, well then what we end up with is water and carbon dioxide coming out of those things with an abundance of energy. Okay, again, not an actual chemical formula, but a diagram that shows us what's going on. All right, now here's the nitty-gritty. Valence electrons and ions. So a valence electron, that is the outside electron within the outside electron around an atom. It's the electron that encounters everything around it. So imagine you're a nucleus and the electrons form a little bubble around you. It's the outside of that bubble that's going to interact with the outside world. So our valence electrons are that outside portion of the atom. Okay, so the outer electrons determine the chemical properties of an atom, and we have what we call the octet rule. And so the octet rule tells us that atoms have a tendency to acquire an outer shell of 8 electrons. So whenever that outer shell is full of 8, it's stable. Just like the noble gases. They're stable because they have 8 electrons in their outer energy level, or 8 electrons in their valence shell. Okay, so the atoms can either gain electrons, pull electrons from some other source, or they can lose electrons. Something might pull an electron away from that particular atom.